Hi, welcome to this lesson video. We're going to be graphing logarithmic functions. Okay, so one thing we have to remember before we can even start is converting a log to an exponential. And so for example, if I had log base 3 of 81 equals 4, and I asked to convert that to exponential form, here's what it would be. 3 to the 4th power would equal 81. So notice the change. The 3 stayed first, but when I converted, the 4 and the 81 switched place, if you will. And obviously we dropped the word log altogether. So another example, what if I had log base 4 of 2 equals a half? Converted, it would be the 4 would stay first, the 2 and the 1/2 would change places. The 1/2 would become a power, and this would equal 2. Okay, so let's look at some of these that I have typed already. Converted, the 2 would stay first, and these would flip, so 4 becomes the power. 4 squared, or 2 to the 4th equals 16. If I come over here, 5 stays first, and these guys switch. So I'm going to have 5 squared equals 25. Here, 7 squared equals x. And then here, 4 to a power of y equals 64. Okay, so that's just basic converting. We're going to need that to be able to graph our log functions. So first thing first, I want to convert just like we've been doing. So this is written backwards. I'll write this one, I'll flip it for you, just for the visual, okay? So the same thing we've just did, the 3 stays first, and then these guys flip places. Power of y equals x, okay? Now if you were, if you watched, or if you've graphed exponential functions, this is gonna be a little backwards than what we did before. Okay, middle of the road, I would love for x to be 3 to the 0 power. So what did I plug in for y to make it become 0? Well, I plugged in 0, okay? And if we go 2 up and 2 down from y, we'll get 5 nice points that will easily be able to see the curve. Okay, so let me kind of fill in. When I plug in a 2 for y, I end up with 3 squared. When I plug in a 1, 3 to the 1st, 3 to the -1, 3 to the -2. Now it's just a matter of whether you use a calculator or you do it in your head. Just calculate these values. 3 squared is 9, 3 to the 1st is 3, 3 to the 0 is 1. Negative exponent does not mean a negative number. It means a fraction. In particular, 3 to the 1st is 3, 3 to the squared, so I'm going to have 1/9 because of the negative exponent. Okay, so now we're just plotting the points 9, 2, 3, 1, 1, 0, 1/3, -1, 1/9, which is even closer to the axis, -2. So hopefully you can see this graph. This is hard to do on my little Moby. Yeah, not too bad. I'm getting closer and closer to that axis, minus that little warbly there. That's not supposed to be. I'm getting closer and closer to that axis, which that means the axis is my asymptote. Now my axis is vertical this time. So remember, vertical lines are x equal equations, horizontal lines are y equals. So since we've got a vertical, our asymptote equation is x equals 0. Since we've kind of hit this wall, that affects my domain, because to the left it appears like I start at 0, but I know I never quite get there, so we're going to do parentheses instead of a bracket on that 0. Then to the right, I don't know where it ends. And then this guy's range, I don't know his lowest point, nor do I know his highest point. So -infinity to infinity. Okay, and that's all it is for logs. Now this next example, you'll notice we have this parenthesis x plus 1. So what that means is when we convert, that's just going to travel together as a group, if you will. So what should be first? 2, and then y equals x plus 1. If you need to flip-flop this around like I did in the last example to see the conversion, you can. I'm not going to, though. One thing that's different here, we have to get x alone because our table wants x numbers, not x plus 1 values. So to do that, I'm going to subtract 1 from both sides. Okay, and notice how I'm going to write this. 2 to the power of y, that quantity, minus 1. So it's a big minus 1. It's not a minus 1 up with the exponent. Okay, so notice that difference. So this is the equation we're going to be using in our table. 1, 2, 3, 4, 5. Okay, and here's what I would love. In the middle of the road, I would love to have 2 to the 0 minus 1. So in other words, what did I plug in for y? I plugged in a 0. Okay, so then go 2 up from that and 2 down from that. So I'd have 2 squared minus 1, 2 to the first minus 1, 2 negative 1 minus 1, 2 to the negative 2 minus 1. Okay, and then just brute force figure out what those numbers are. 4 minus 1 is 3, 2 minus 1 is 1, 1 minus 1 is 0, 1/2 minus 1, negative 1/2, 1/4 minus 1, negative 3/4. Okay, so let me plot these points. 3, 2, come on, there we go, 1, 1, 0, 0, negative 1/2, negative 1, negative 3/4, negative 2. So hopefully you can see I'm getting closer and closer to this negative 1 there. Okay, so when I connect my dots, I'm getting closer and closer to that dashed line. So that means my asymptote equation is x equals negative 1. My asymptote shifted. My domain, negative 1 to infinity. And then my range, negative infinity to positive infinity. Okay. One more example, and that should be good for graphing these logs. What if we've got something like this? Notice we have this minus 1 that's outside of the parentheses. Well, before I can convert, I need to get my log alone, okay? So to do that, I'm going to add 1 to both sides. So really, I've got y plus 1 equals a log, and this is what I'm going to use for my conversion. I'm going to have 4 first. This travels together as a group and becomes the power equals x. My x is alone, so I'm ready to start looking at my table. 1, 2, 3, 4, 5. So middle of the road, I would love for x to be 4 to the 0 power. So what did I plug into y plus 1 to make that expression turn to 0? Well, I had to do a negative 1. Negative 1 plus 1 would have made the 0 that I wanted. So then go 2 above and 2 below, and that'll give me good points to work with. So when I plug in a 1, 1 plus 1, 4 squared. When I plug in 0, 0 plus 1, 4 to the first. When I plug in negative 2, negative 2 plus 1, negative 1. When I plug in negative 3 plus 1, negative 2. Brute force, figure out these numbers. I'll just write them real quick. Remember, negative exponents mean fractions. Okay, so when I plot these points, 16, 1, so 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12, 13, doggone it. All right, so about here. Sorry, I don't want to lose it in that table. Let's say that's the point 16, 1, 4, 0, 1, negative 1, 1/4, negative 2, even closer to the axis, 1/16, negative 3. So again, I'm getting closer and closer to that axis. So that's going to be my asymptote. Let's try this. Maybe it'll make a better line. There we go. So there's my asymptote. So my asymptote equation, x equals 0. My domain, 0 to infinity. My range, negative infinity to positive infinity. Okay, so that's about it. That's the basics to graph a log. Keep learning, have fun, and I'll see you next time.